video notes. Here I am, take a notebook out, let's start the jam. Video notes, here we go. Take a notebook out, let's start the flow. Video notes. Hey everybody, welcome to this week's installment of video notes from Mr. Flugum's physical science class. This week we're talking about magnetism and electricity. And the big thing is this: how do you use magnets to make an electrical current? Well, these notes will go on page 54 in your physical science notebook. Thanks for tuning in. Let's get started. Well, you might be wondering, what is this all about? All right. How are electricity and magnets related? Well, that's what we're going to explore. And during this PowerPoint, we'll kind of cover these four things, right? We'll define and describe what a magnet is and what a magnetic field is. Okay? We'll explain how electricity and magnetic fields interact. And we'll also talk about how do you make electrical current when you have a magnet. All right, so here we go. All right, so let's start with what a magnet is. So you can see the definition there. All right, it's an object that's surrounded by a magnetic field. And just so you know, magnetic field is the area around the magnet, right, where it can exert force or affect things. All right. Magnets can exert force through space. So that means this: they don't have to touch something to actually have an effect on it. That magnetic field can affect things that are not directly touching the magnet. And you've seen this before, right, where you get two magnets close to each other and all of a sudden they snap together, or maybe they push apart. Okay, so that's kind of what a magnetic field is and a magnet is. So magnets have two sides to them. They're called poles, right? And they're named north and south. And just like charges, opposite poles attract, like poles repel. You can see the picture there, right, with the north and south pole when they come together. All right, their field lines kind of show that they work together in the same direction. Whereas with the two south poles that I have next to each other there, you can see the field lines are in opposite directions, so they will repel each other. The magnetic field won't really work together. All right, so magnetic fields and electric fields. So just like magnets, electrical charges also have an area around them where they can affect things or exert force. All right, and you can see there in the two illustrations that I have for you that magnetic fields and electric fields look very, very similar. And they are related. They have a very intimate relationship, okay, where electric charges can make magnetic fields, and then vice versa. Magnets have an effect on electrical charges. So let's get into that a little bit. So electrical charges form magnetic fields. This is something we're actually going to do. All right. So moving electrical charges make a magnetic field. All right. And if you take your hand, all right, your right hand, okay, and you point it in the direction that the charges flow, your fingers show the direction of the magnetic field. All right, the way that your fingers would wrap around that current. All right. So when you just have a single wire, right, that magnetic field is really weak. There's not much to it there, even when you have lots of current. But if you coil the wire up, we can make that magnetic field really strong by concentrating it together. In fact, we do this quite often. Some of the strongest magnets that we have are called electromagnets. Okay, and they're very powerful just by running a current through lots and lots of coils of wire, and having an iron core makes a really strong magnet. All right, so by changing the magnetic field around a wire, we can produce electric current. All right, you can see in the illustration there, okay, moving the magnet into the coil of wire will cause voltage. Okay, moving the magnet out of the wire will also cause voltage. Okay, but if the magnet's not moving, it won't cause any current or any voltage difference. So yeah, the magnet has to be constantly moving in order to keep a continuous electrical current flowing. All right, and this is kind of a weak thing with a single wire, but if we coil up that wire, just like with an electromagnet, we can increase the effect of the moving magnet. So by using a magnet on a coil of wire, This is to make electricity. This is called electromagnetic induction. All right. And this is basically how generators work. All right. So to make an AC current, we take a magnet and we spin it in a coil of wire. You can do that lots of ways, right? They do that in hydroelectric dams and nuclear power plants. They do that with gasoline and natural gas engines. We do all those kinds of things to produce electricity, all in the same manner, by spinning a magnet in the coil of wire. Well, thanks for tuning in, folks, and I will see you on Thursday or Friday in class. Have a great day.